Have you ever seen a string that starts with a mysterious R? Or maybe you've noticed that Windows file paths are sometimes written with double backslashes. Believe it or not, these two things are secretly connected. Picture this. You're building a Python program that needs to read data from a file. You've written the code, you know exactly which file you need. All that's left is to grab its file path. So you open the File Explorer, navigate to your file, and copy the path. You paste the path into your code and run it. Wait, what? An error? We just copied this path directly from File Explorer, so why doesn't it work? The answer has to do with something called escape sequences. In Python strings, like our path here, the backslash character has a special meaning. When Python sees a backslash followed by certain letters, it doesn't print them literally. It interprets them as instructions. For example, if in another cell we print a string with \n in the middle, Python doesn't print the backslash and the letter n. Instead, it inserts a new line, like pressing enter on our keyboard. Combinations like \n are called escape sequences. They let us represent things we can't easily type, like new lines, tabs, or special characters. Besides \n, another escape sequence is \u, which is used to insert characters that aren't on your keyboard, like emojis or symbols. This is exactly what caused our error. Python saw \u at the start of users and tried to interpret it as one of these special sequences. But the escape sequence, \u, expects a character code to follow it, and this is not a valid code. So Python threw an error. And even if that had worked, \n in notes would have been interpreted as a new line sequence. As we saw before, this would have broken our path string onto multiple lines, creating an invalid path. Okay, now that we understand the problem, how do we fix it? One option is to use another escape sequence, double backslash. When Python sees two backslashes in a string, it treats them as a single literal backslash. So double \u becomes just single \u. Escape sequences are only processed once. Python won't look at this \u and try to interpret it again. Running the code now, we no longer get an error. We see the contents of our notes file. Great, but manually doubling every backslash is tedious. And if you only fix the problematic sequences, it's easy to accidentally miss one. There are lots of escape sequences in Python, and memorizing them all isn't practical. If you want to see the full list, check the link in the description. Fortunately, Python gives us a way to avoid escape sequences altogether. R strings. By writing an R before the opening quote of a string, we create what's called a raw string. In a raw string, backslashes are just backslashes. Python doesn't try to interpret them as escape sequences. That means \u and \n in our path stay exactly as we typed them. Now, if we run this code, it works perfectly. And if we print the raw string itself, we can see it includes the backslashes. Awesome! R strings are useful whenever you're working with strings that contain a lot of backslashes. Windows file paths are the most common example. But there's another big use case: regular expressions. Regular expressions use backslashes constantly for special patterns, and R strings make them much easier to write and read. If you want to learn more about regular expressions, check out the video linked in the description. We also linked a practice workbook where you can try out R strings and escape sequences yourself. And if you want to go deeper on working with files, check out our video on file handling. We're working on lots more Python explainer videos like this one, so be sure to subscribe so that you don't miss out. If you have any questions or topics that you'd like to learn about, Let us know in the comments below. We'd love to hear from you. Thanks for watching!